I'm going to begin by showing you the participation assignment that I want you to do. And it's real quick. So this will be an easy, I'm going to only give you 5 points today. Usually class participation is 10, but here's what I want you to do. I want you to go into Canvas, go into collaborations, and you'll see February 2nd participation. And it's a shared Google Doc. And you can only do it on the Google Doc if you have like a tablet that you can write on. If you don't have a tablet that you can write on, there is an assignment on Canvas where you can just do this on a separate piece of paper and upload it and post it to Canvas, okay? Otherwise, if you do it on this shared document, then put your name next to it so I know who to give credit for. But anyway, here's what I want you to do. I don't want you to mark right on my drawing, okay? So I want you to take my drawing, I want you to copy it, right? And there's actually 2 different drawings here. There's this one and this one. So you're going to copy it. You're going to come down here and enter, right? You're going to paste it in. And what I want you to do is draw one line on the document that you want to add to this drawing. The goal is to solve for X, okay? But you're going to do this from a student point of view, and I need some of you to give some really bad answers, okay? So I don't usually assign groups by male, female, but I think in this case, I'm going to say if you're a male, please give a really bad answer, okay? Give a line that would totally not help at all, okay? And then females, go ahead and give a answer that would make a little more sense, okay? So please remember to copy and paste so that there's always one blank drawing for the next person to copy and paste. And I'll compile all these drawings, and then that will be part of our lesson plan for Thursday. All right, so then moving on to something different, I asked you to download the standards document. Okay, so these are the most recent, the next generation standards. And in your teaching career, you are going to see the standards document update over and over. Every couple years, things slightly change. Sometimes we end up with a very radical change, like what happened with Common Core, where things changed very radically in a short period of time. So this is just constantly changing and evolving. And later, a few lessons later, I am going to take a little bit of time to kind of look at the history behind this and how we got here. But anyway, let's start talking about this very first page here. And on this first page, over in the left-hand column, those are called, and actually they're a little bit inconsistent with their language throughout this document. In the elementary school, they call these the domain here on the left-hand side. Do keep in mind that this entire document is a K-12 document, okay? But we start, right? You can see the chicken scratches I have here over along the side. We start basically with, I mean, they should know fractions when they get to us in 6th and 7th grade, according to this document. I can tell you as someone who's teaching pre-calc at SUNY Geneseo, I have a whole day of reviewing fractions. So obviously they don't know those before they get to 6th and 7th grade, but that's a story for another day. So anyway, we basically start here in 6th and 7th grade. By 8th grade, we go into the number system and expressions and equations. By the time we get to high school, they call what is over on this left-hand side. Here, let me use a text box. And if you're taking notes, I mean, I don't recommend that you print this entire document. When we were in class face-to-face, I did print for all the students this very first page. All right, so maybe you would like to print this first page and keep this in your notebook as a reference, okay? But don't print the whole thing. It's like 200 pages. So anyway, these documents on the left-hand side are called, these not documents, these categories, right? These are called conceptual categories. So like I said, when they start off with the elementary, they're calling these domains. When you get to high school, they will call these conceptual categories, and then below that is what they would refer to then as the domain. And so on Thursday, after we do a sample lesson plan, we're going to talk more about these standards as well. And this is what's going to help you pick the topic for your research project, is we're going to start looking at what's there in the middle school and high school curriculum. And you can pick a topic that's interesting for you and decide that that's going to be your topic for your research project. So anyway, these are skill-based standards, or these contain skill-based standards, okay? So we have two different things. We have our process standards and our content standards, okay? So on the left-hand side, this relates to content. Over in here, and what this is showing, I mean, the reason they made this visual the way they did is they're showing that every single one of these process standards is supposed to run through the content standards, okay? There are 8 process standards, and known as the standards for mathematical process. And again, you're going to have to get used to some abbreviation. So my abbreviation for this is SMPs, right? So there are 8 SMPs. Okay, then there's a lot of stuff you can read here. Okay, if we go on to this page, and I highlighted a few things that I want to read together. You're welcome to read any and all of this, but here's something that I want to highlight, because this paragraph I think does a really good job of describing the interplay between process standards and content standards. Those words, just in a recent video, I talked about procedural fluency, what we want them to learn how to do, but conceptual understanding, how we want them to understand what's behind it. All right, that's somewhat related to the idea of skill versus mathematical process. Okay, so there are two different things that are equally important. Okay, so anyway, I suppose I can read to you. I mean, you can all read to yourself, but let me read and highlight some of the parts. Okay, so the whole document, all of these standards, right? Define what students should understand and be able to do as a result of their study in mathematics. A teacher must assess whether the student has understood what has been taught and provide opportunities where students can use and apply their knowledge, right, in similar and in new contexts. Okay, so you do mathematical application when you can take a skill and you can transfer it over to a new situation or problem, right? And that's really what problem solving is. A lot of times students think problem solving just means I gave them a problem and then I told them to solve it, right? But problem solving involves, can you come to an unfamiliar situation and transfer in some skills that you've learned and pick and choose what skills you need to solve that particular problem, okay? And so that's what is involved in mathematical application, which probably if you're doing application, it involves some problem solving, okay? So we want them to be able to do that in similar or new contexts, okay? While procedural skills are relatively straightforward to assess, and that's one of the reasons that I think sometimes the conceptual understanding piece might get neglected in favor of procedural skill, because procedural skill is really easy to assess, right? It's really easy to write a test that assesses procedural skill. You give them a bunch of problems and you see if they get correct answers, right? That's how we assess procedural skill, easy as can be, right? Trying to assess conceptual understanding, sometimes that's not really a quantifiable thing, right? Procedural learning is very easy to quantify. Conceptual understanding, a lot harder to pin down. Okay, and then here we go. Teachers often ask, what does mathematical understanding look like? That's a much harder question. Okay, one hallmark of mathematical understanding is the ability to justify. Let's see, I'm not going to read every word. All right, so we want to justify. And then in order to justify, language is important, right? Articulate it with correct language. And it talks here about the importance between recognizing the difference between mathematical understanding, right? Conceptual understanding versus procedural skill, okay? That's important to recognize within the curriculum, but also within our assessments, right? And like I said, assessing conceptual understanding is very difficult. All right, can be done, but it's difficult. And then I like the example that they give here, right? The difference, what would it mean as far as, our old high school friend FOIL, which we're supposed to not say FOIL. I don't know. I like FOIL personally. Some people say you shouldn't use FOIL because FOIL is not a proper mathematical term and you should call it double distribution, right? Which I agree that double distribution is a more accurate mathematical phrase. But I like the way they describe it in here, the difference between procedural fluency and conceptual understanding. All right, so a student might memorize FOIL and get the problem right? And they get right answers and we're all happy. But then the difference is someone who can explain what it means. And then if you have conceptual understanding, then you can transfer your understanding of FOIL into a more complicated problem. And that's what we're talking about up in here, applying your knowledge to a new or similar context or problem. Okay, so that's how we know they have conceptual understanding, if they can apply what they know to something similar yet different. So I thought this paragraph was great. And then a couple other places I highlighted in here. Let's see, we're going to be looking more carefully at this page on Thursday, how to read the standards. So here are our SMPs, right? Our standards for mathematical practice. And part of the homework tonight is I would like you to read over these and don't worry about it if you don't understand every word. And I'm not going to have you write a summary on your article summary sheet. First of all, this isn't an article, so it doesn't belong on the article summary sheet. But if you want to take notes, take notes. If you want to just read them over, these will be something that we keep going back to throughout the course. So, like I said, don't panic if you don't fully absorb everything right here today. But anyway, our 8 SMPs. Okay, first one, problem solving, and persevere in solving problems. So no matter what topic we're on, we want the students problem solving within that conceptual category, right? Within that topic of mathematical skill, we want there to be problem solving. Okay, so that's a process. Okay, we want them to be able to reason. What do these words mean? Reason abstractly and quantitatively. I'm not going to try to address this in this video segment, but I have a little lesson on what it means to reason. Okay, so we'll get back to that. Certainly when you read this, I know the first time I ever read this, I felt like I didn't understand it at all. So we'll come back to this one and try to get a better handle on what it really means to reason. You probably sort of have an intuitive sense of what reasoning means, but what does really mathematical reasoning and reasoning abstractly in mathematics, what does that really mean? So number 3, construct viable arguments and critique the reasoning of others. So we want students talking to each other. All right, that's really important. In this place and time, that's not happening so much. Unfortunately, that's one of the big things we've lost out on here with COVID. And I can't wait to have you guys in person in class, because I want you guys, constructing viable arguments and critiquing the reasoning of one another. I want you guys doing that. So it's very important to have students talking to each other. Model with mathematics. Okay, so it's very important that we can take a problem and create a real world problem and create a mathematical model to give us information about a real world phenomenon or problem. Okay, so that's modeling. And then using tools appropriately. Okay, so that might be a calculator, a graph paper, constructing a graph, some sort of model. It might mean some geometry software, things like that. And attend to precision, that's a pretty easy one. Attending to precision means like you label your axes, when you draw a line, you write the equation on the line, you round to the place that you're told to, right? When you find area, you don't just write 10, you write 10 centimeters squared. That's attending to precision. There's also precision in our language. For example, I have heard students say fairly often and heard teachers say, oh yes, that's right. I've heard students say things like triangles have 180, right? And then the teacher will go, oh good, yes, triangles have 180, right? We all know what is meant, but attending to precision would be to correct that student and say the sum of the angles in a triangle are 180 degrees. Okay, so that's precision. So you will read, when you read the look for and make use of structure, you got the Aaron Harris version of look for and make use of structure, right? You got my interpretation of this standard. When you read what they write, it's different than how I described it. And then look for and express regularity and repeated reasoning. Later on, I have a lesson from my pre-calc curriculum that I'm going to show you that I think is a prime example of what this SMP, this standard of mathematical practice, can look like in a lesson. So other examples, though, of expressing regularity and repeated reasoning, even just things like, what does this look like versus what does this look like, right? And seeing patterns among related classes of things. I would argue that can be a regularity and repeated reasoning type of thing. So we are going to spend more time on this document on Thursday. We are also going to do a sample lesson on Thursday. So Thursday, I'm going to bring you in synchronously live, and we'll be able to go into breakout rooms, and hopefully Thursday's lesson, I hope, is a little more interactive and interesting and fun than this lesson. I hate to have the first day be so much of just me talking, but I decided when I found out we were virtual for the first week, I changed some things up and put some of the boring stuff and the informational stuff right at the beginning. But I promise you, I have lots of interactive lessons planned for you, and hopefully we can really get on those when we get into person. So thanks for watching.